Let's start with the 18th question. Here, before I start with the partial fraction, I have to assume something, right? Because you can see that the fractions given here is not in proper form. Degree of numerator and denominator is same. So I am assuming x square as y or t, but this assumption will not be considering integration. I will just keep this uh, assumption to simplify my term. That is, I will not write this x square and again and again. That's why I am assuming x square as t. But this assumption is not for the integration, but for to solve this fraction. So I will just keep this value of t as x square before I integrate. Okay, I am not taking this assumption in integration. So I will keep this substitution before integration only. So t plus 1 and t plus 2 upon t plus 3 and t plus 4. So this will be t square plus 3t plus 2, whereas this will be t square plus 70 plus 12. So you can see that I can make this as t square plus 7t plus 12, but I have to subtract 4t and 10 from here. So I will individually divide this. So this will be 1 minus bracket 4t plus 10 upon t plus 3 t plus 4. Right. Now I will partial fraction. This we will use the concept of partial fraction to write it in the form of a upon t plus 3 plus b upon t plus 4. So if I cross multiply this, then I will have a into t plus 4 plus b into t plus 3. So here I will assume t as minus 3. So minus 12 plus 10 will give me minus 2, and 4 minus 3 is 1. The value of a is minus 2. And if I assume t as minus 4, then minus 16 plus 10 I will have minus 6. And here a will get eliminated and b will be minus 1. The value of b is 6. So keeping this, I will have 1 minus 4d plus n upon this can be written as minus 2 upon t plus 3 plus 6 upon t plus 4. So if I open this bracket, then I will have, and as I told you that I will keep the value of t before integration only, as the substitution was not for integration, it was just to make my sum somewhat simple. So again I am replacing the value of t, and then I will integrate. As you can see that this is the simplification of this. So integration x square plus 1 x square plus 2 upon x square plus 3 x square plus 4 dx. So I can replace the value of this, which I have found out, as 1 plus 2 upon x square plus 3 minus 6 upon x square plus 4 dx. Right. So integration of 1 is x, 2 will come outside. This is of the form 1 by a tan inverse x by a. And 6 will come out, and again this is of the form 1 by a tan inverse x by a plus c. The final answer is x plus 2 by root 3 tan inverse x by root 3 minus 3 tan inverse x by 2 plus c. This is your final answer. Yes. Let's understand the 19th question. Integration 2x dx upon x square plus 1 x square plus 3. Mind well, here I will substitute this x square as t in integration only. So 2x dx will become dt. So no need to write it x dx. 2x dx is there. Right. So this will be dt upon t plus 1 t plus 3. So if I write this, you can apply partial fraction, but it seems very easy for me to do it like this. So I am doing it. Otherwise, you can apply partial fraction. See, if I subtract this, then dt will get cancelled out, and 3 minus 1 will give me 2. But I want 1, so I am dividing 2 outside. So if I divide this individually, then I will have 1 upon t plus 1 minus 1 upon t plus 3 dt. So taking integration will give me log mod t plus 1 minus log mod t plus 3 plus c. So I will apply the properties of log, then I will have t plus 1 divided by t plus 3 plus c. So here I will replace the value of t as x square. So my final answer is half log mod x square plus 1 upon x square plus 3 plus c. Yes, correct it is. Let's try to do the 20th sum over here only. I think it will get complete over here. The question is dx upon x into x square x raised to 4 minus 1. So I am multiplying x cube in numerator and in denominator. So here I will assume x raised to 4 as t. So 4x cube dx will be dt, and in turn this will be x cube dx will be dt by 4. So replacing or substituting the values, this will be dt by 4. X cube dx will be dt by 4, and this will be t bracket t minus 1. So 1 by 4 will come outside, and I can write this 1 in new format as t minus. Right. So if I subtract this t will get cancelled, and I will have just 1. You can use partial fraction if you are not getting. Using partial fraction, you will get the same value. So if I divide this individually, I will have t minus 1 minus 1 by t dt. So if I take integration, I will have log mod t minus 1 minus log mod t as c. So if I apply property of log, then I will have replacing the value of t as x raised to 4 minus 1 upon x raised to 4 plus c. So this is your final answer. 1 by 4 log x raised to 4 minus 1 upon x raised to 4 plus c. Yes. Let's try to understand 21 question. It is given dx upon e raised to x minus 1. So I will multiply e raised to x in numerator and in denominator, and I will assume e raised to x as t. So e raised to x dx will become dt. So this will be dt upon t bracket t minus 1. You can use partial fraction for this, but I can directly solve this as it is somewhat easy. I will subtract t minus 1. So here dt will get cancelled and I will have 1. So if I individually divide this, then I will have 1 upon t minus 1 minus 1 upon t dt. Taking integration will give me log mod t minus 1 minus log mod t plus c. Applying properties of log will give me t minus 1 by t plus c. Replacing the value of t as e raised to x, my final answer will be log mod e raised to x minus 1 upon e raised to x plus c. Right. Let's try to understand 22. Integration x dx upon x minus 1 x minus 2. So I want to write x upon x minus 1 x minus 2 as a upon x minus 1 plus b upon x minus 2. So if I cross multiply, then I will have a into x minus 2 plus b into x minus 1. If I assume x as 1, then 1 is equal to a into minus 1 will give me the value of a as minus 1. And if I take x as 2, then 2 is equal to 2 minus 1 1. I will have the value of b as 2. So replacing the value, I will have x upon x minus 1 x minus 2 as minus 1 upon x minus 1 plus 2 upon x minus 2. So taking integration on both the sides, minus 1 integration 1 upon x minus 1 dx plus 2 integration 1 upon x minus 2 dx. That is minus log mod x minus 1 plus 2 log mod x minus 2 plus c. But I don't think so. This is the format given in answer. The form, so I have to write this as, I will take this 2 in power and applying the properties of log, I will have x minus 2 whole square upon x minus 1 plus c. Right. Yes. Here B option will be the correct option. Question number 23. Here it is given integration dx upon x bracket x square plus 1. So I will multiply x in numerator and in denominator. Now I will assume x square as t. 2x dx will become dt and x dx will be dt by 2. So integration dt by 2 upon t bracket t plus 1. So 1 by 2 will be outside the integration, and I will write this 1 in new format as t plus 1 minus t. If I will subtract, I will get that same 1. So if I individually divide this, then I will have 1 by t minus 1 by t plus 1 dt. This will be log mod t minus log mod t plus 1 plus c. If I replace the value of t as x square, and giving this 1 by 2, applying the property of log, I can write log x square as 2 log x. These two will get cancelled out, and I will have log mod x minus 1 by 2 log mod x square plus 1 plus c. A option is the correct option.